right, guys, 1-7, functions. We're going to determine whether a relation is a function, and we are going to find out about function values today. Second one being a new idea. The first one we have had before. Here are our vocabulary words. Go ahead and write those down, and we will define them as we move along today. But please make sure you take a minute to write those down so you don't miss any in your note taking. A function, here's your first definition, is a relationship between input, need my highlighter, between input and output. There is one and only one output for each input. Okay, let's look and see what that means. A function is a relation, there's another way to say it, in which each element of the domain is paired with exactly one element of the range. So every x, now I don't need it. Every x, every domain or x value is paired with only one y value or range. Okay, so if I have -3, it can only be with one y value. I can't have an ordered pair -3, 1, and an ordered pair -3, 0. Then it would not be a function. Okay, and if you thought about that, if I graphed both of those -3, 0, and -3, 1, don't forget, we're going to talk about vertical line tests in a minute. Okay. Here is some of your homework type problems. Determine whether each relation is a function and explain. Okay, we have -2 paired with -3, 0 paired with 6, 3 paired with 6, 4 paired with 9. Is this a function? Yes, it is. Why? Because there is one domain or one x value with each y value. Yes, we do have 2 y's, but you can have the y value repeat. It's the x value that can't repeat. 0, 6 and 3, 6 can be in the same function. The y value can repeat itself. It's the x value that can't. There can only be one input with one output, but there can't be the other way around. Okay. How about this guy right here, the domain and the range? In this case, 1 is paired with 4, and 1 is also paired with -4. The domain can only be paired with one range, so this is not a function. Go ahead, look at this set of ordered pairs and determine if this is a function. A graph that consists of points that are not connected. So if we had something that looks like this and the points are all over the place, that would be called a discrete function. If we have something that graphs and it creates a line or a curve, right? Then it's called a continuous function. Discrete and continuous. A continuous line, continuous curve, continuous function. So that's another definition for you. Okay, at ice sculpting competition, each sculpture's height was measured to make sure it was within the regulated height, 0 to 6 feet. We're going to draw some graphs based on this data that we're given for this ice sculpting. So we have team 1 that has 4 feet, team 2 is 4.5 feet, 3 is 3.2, 4 is 5.1, and 5 is 4.8. So the first thing you're going to do is make a table showing these relations. So we have the team and we have the height. Okay? We can consider that x and that y. So team 1 is 4 feet, team 2 is 4.5 feet, team 3 is 3.2 feet, team 4 is 5.1 feet, and team 5 is 4.8 feet. All right, determine the domain. So now we have our table of values. Let's determine what the domain and the range is. The domain is 1, 2, 3, 4, and 5, right? That would be our domain. And our range is 4, 2 is paired with 4.5, 3 is paired with 3.2, 4 is paired with 5.1, and 5 is paired as 4.8. Well, let's take that information and graph those ordered pairs. So we had, ooh, gosh, go back. So we have 1 and 4 and 2 and 4.5. Over 1 up 4, over 1, over 2 up 4.5. Get a couple more. 3, 3.2, 4, 5.1. Over 3 up 3.2. Over 4 up 5.1. And our last one is, oh, where'd you go? Over 5 up 4.8. Over 5 up 4.8. Okay. Do we have, so we've graphed the ordered pairs, and I expect you to do a better job than that. Label them if we can, but we may not have enough room to label. Just make them, make sure you're oriented across those x-axes and y-axes like I can't do very well. And then, by looking at this, do we have a discrete or a continuous function? Can you tell me, is it a discrete or a continuous function? Is it a continuous line here? No. So this is a discrete function. Okay? All right. Here's your example with the bird feeder. You go ahead and make your table, determine the domain and range, write the data as a set of ordered pairs, graph it, and then determine if it's discrete or continuous. All right. Vertical line test, I've been refreshing your memory about this for a little while. So remember, one way to perform the vertical line test is to use a pencil. Place your pencil on the graph and move it from left, from here to there, but hold a pencil up and move it across and see, does the pencil pass through more than one point? And in this case, this is a function because it never passes through more than one point. Now, if we look at this one, it's not a function because if I do a vertical line test, you can see it passes through 2 points. And if I did it out here, it also passes through 2 points out there. And this one is also a function because this one does not intersect that line and that one does intersect that line. Equations can represent a function too. You know, we talked about equations representing a relation. They can also represent a function. And every solution, oops, stay here. Every solution to an equation is a point on the graph. And all the solutions together are going to make a line or a curve. Let's look at these. So here we have negative 3x plus y equals 8. Let's make a table and a graph. Well, remember how we did this, guys? X and y. If x is negative 1 times negative 3 is a positive 4 plus y equals 8. So what's y going to equal when x is negative 1? It's going to equal 4. How about when it's 0? 0 times negative 3 is 0, so y equals 8. So in that case, it would equal 8. How about when x is 1? Negative 3 times 1 is negative 3 plus y equals negative 8. What's y going to equal when x is 1? Add 3 to both sides, it'll be negative 5. And how about when x is 2? Did I do that right? I did not do that right. That would be, excuse me, negative 3, darn it. Well, I'm running out of battery. Hold on here a second. All right, sorry about that, guys. A little distracted by the battery. And actually, what I did is I wrote down that, oh, don't do this to me, that negative 8 instead of a positive 8 right here in this solution. So negative when x is 1 times negative 3 is negative 3, right? Plus y equals 8. Well, in that case, then, y will be 11. And finally, 2 times negative 3 will be negative 6 plus y equals 8. And then in that case, y would equal 14. All right, and then you could graph those ordered pairs, and, right, because we have the ordered pair negative 1 comma 4, right, 0 comma 8, 1 comma 11, and 2 comma 14. Okay, over negative 1 up 4, over 0 up 8, over 1 up 11, and so on. And you can see we're going to get a straight line, aren't we? And that is going to be a continuous function, of course, right? Do you like that? Make a table and a graph? I did make a graph on this one. Okay. A function can be represented lots of different ways. It can be a table, it can be mapping, it can be the equation, and it can be a graph. We've looked at all of those, right? All right. Function notation. Now, this is sort of a new idea for us. We really haven't talked about this very much. Functions are indicated by the symbol f of x. Okay. So f of x is read f of x. It could be other letters, but we generally use f of x. All right. Equations that are functions, they can also be written in a form called functional notation or function notation. So an equation and a function notation are basically the same thing. Let's consider this example, y equals 3x minus 8. When we write it in equation form, it's y equals 3x minus 8. However, if we wanted to write it as function notation, we'd say f of x equals 3x minus 8. So really, you know, this is sort of like y. And in fact, in a function, x represents the elements of the domain, okay? Right? We know that. F of x represents the elements of the range. So in fact, y and f of x represent the same thing. They both represent the elements of the range. Suppose you wanted to find the value in the range that corresponds to the element 5 in the domain, right? So we had 5 in the domain, and we wanted to find the value for the range. This would be written f of 5. That is what y would mean in this case. So the way we'd find that is we would substitute 5 for x in the equation itself. Let's watch how that happens. So here we have f of x equals negative 4x plus 7. Now, if we have f of 2 for f of x, right? So x is 2 in this case. We would substitute in a 2 for f of 2, right, is negative 4 x plus 7, right? So if we're substituting in every place there is an x, we're going to put a 2. So f of 2 would be negative 4 times 2 plus 7. So that would be negative 8 plus 7. F of 2 is actually equal to negative 1. So what we've done is it says f of 2, we're substituting in the equation 2 for every place that there's an x. Let's try another one. In this case, we have negative 4x plus 7 again, right? F of x. But in this case, f of x is negative 3 plus 1. So wherever there's an x in the equation, we're going to substitute this. So f of negative 3 plus 1 is negative 4. Now substitute in negative 3 plus 1 plus 7. So what's negative 4 times negative 3? Negative 12 plus 8. All right, did I do that right? So that would be negative 4. Okay, guys? All right. The next, what do we have? Here's some practice problems for you. Go ahead and try these and see what you get. Oops, we got to go back. Sorry, guys, I'm boo-booed. We have to bracket off negative 4 minus 3 plus 7, or make a bracket, and then add our 1. So negative 4 minus 3 times a plus 7. So that's negative 12 plus 7 is positive, hello. That's what I did wrong up here. That's all I did wrong. Okay, back. Anybody else catch my error before? Huh? This is a positive 12 plus 1 plus 7. That's all I did wrong. Not a negative. So 12 plus 1 is 13 plus 7 is 20. So we are all right how we set everything up. Just wasn't paying attention to my signs. Nobody ever makes that mistake, right? Okay, I'd like you to just do 4A and 4C and try 4B. Don't panic if you don't get 4B. We'll do it in class, but try it. See if you can get it. Take the challenge. All right. A function with a graph that is not a straight line is called a nonlinear function. That might be your last definition, I think. Nonlinear function, not a straight line. Duh, that makes sense. All right. If we have h of t, which is sort of like saying f of x, but they have to change it up on us, right? H of t. That means, and we have equals negative 16t squared minus plus 68t plus 2. We need to find each value. So when h of t is h of 4, that means we're going to substitute a 4 every place that there's a t in the equation. So in fact, negative 16 p squared times 4 squared plus, here's a t here, right? 68 times 4 plus 2. And you solve it for that, and you get negative 256 plus 272 plus 2 equals 18. So when h is 4, h of 4, then we'll substitute the value of 4 into every place in the equation to find out what our h of 4 will equal. So h of 4, right, would equal 18. That's like saying our output is 18 or our y is 18. That's what this means. All right. In this case, we were still at that other equation, 16t squared plus 68t plus, was it 2? I'll have to go back and check. Plus 2, that's right. Okay. Now, every place that we have a t, we're going to insert this. All right? So 2 times h of g, right, is going to insert into here. So we're going to do 2 times this whole bracket. Negative 16 times, what are we substituting in for our t? We're substituting in the g squared plus 68g plus 2. 2 times negative 16 is negative 32g squared. 2 times 68 is what? 164? No, that's not right. What is that? 136. Sorry, g plus 2. And so there is our solution. 2h of g is negative 32g squared plus 136g plus 2. Try one of these, maybe two of these. Let's try these two right here, the easy guys. We'll look at these tomorrow. And then it's for this equation, if f of t equals 2t to the third power. Okay, good luck with that, guys. And that's the lesson. We can just ignore this. I don't even know what it's doing there. Goodbye. Delete. Okay. Good luck, and sure you'll have some questions. Don't panic. Review the parts that were hard. Listen to that part again, and be ready to ask really good questions next class. Thank you, guys.